All right, I'm going to talk through adjusting the speed controller for the governor and the magnetic actuator on an MEP 831 Alpha. And I'm also going to talk about adjusting the manual governor. And by the manual governor, I'm not necessarily talking about this on my machine. This screw is completely removed and it was down in the little sump down there. Supposed to be a wire through the top of this bolt with like a little lead not tamper proof, but just so it's not tampered with and tied off so you can't adjust it. Anyway, the tools you're gonna need will be a little teeny tiny flathead screwdriver, 3/8, 7/16, and 1/2 inch. Some of these are from other work I was doing on. A tool you're gonna also need as well is like a dial caliper or something like this to measure with. The technical manual for this generator is TM 9er-611-639er-13 in P. That means for the parts. I'll splice in a little note right now that says what page in the PDF file this is. It's work group 20. But anyway, there's a whole bunch of pages on this. A file I got from one of the people at Steel Soldiers was this little 11-step procedure for adjusting it. And basically it's a consolidated version of what's in the TM. TM has pictures and stuff like that, but since you found this video, I'm going to use this along with what I learned about adjusting the mechanical governor and point you and talk you through it. It would have been impossible for me to record me actually doing the work to do this because I think I spent almost 4 hours today. What I want to start with is this screw. If yours is missing on this, some of the guys at Steel Soldier Forms, they told me the way it was adjusted on their machines was between 0.765 and 0.793. That's the measurement from the metal ridge right here to the top of the bolt. Now you can see even mine, it was bent a little bit. So you're going to want to measure, get yourself somewhere near there, and then what you're going to need to do is tweak it a little bit. If you have some of the problems that I'll point out here in a little bit. So the first step you're going to start with says loosen lock nut on bottom of actuator linkage rod. Adjust spherical nut so that one thread shows on the bottom of the spherical nut, and then tighten the lock nut against it. This is the linkage they're talking about. The black nut right there is the spherical nut that goes into the bottom of the governor. It's kind of rounded at the bottom, and that's the jam nut. By the one thread, you can't see it right here with it in the machine, but you can either pop this out to the side or just completely remove it, and you'll see this threaded part does come to an end. You want to take this nut, loosen it off, and then bring the spherical nut all the way down, and then start bringing it back up until you see one thread out the bottom. Take this jam nut, tighten against it. Tighten it good. There's a lot of vibration in here. I made a mistake when I was adjusting mine of not tightening all this stuff good enough, and it moved and it screwed me up real bad. The second step is make sure the actuator lever reaches its stop just prior to the engine fuel lever reaching its stop. And that adjustment is made from up top here. This is the fuel lever it's talking about, because this controls So you got your magnet right here, and it pulls in and out, and that adjusts how much fuel is being injected by the mechanical fuel pump right here. Now, yeah, you want to adjust it, but what's more critical is the next step. So what I did on mine was I sort of skipped around a little bit right here. You'll see we would have been on step 3. I went to step 4 and I turned the gain and stability potentiometers on the speed controller all the way counterclockwise. That turns them all the way down. That's stability is on the left, gain is the one next to it. I turned them all the way counterclockwise. The reason why I did it is after messing with the linkage and stuff in there, as soon as you'd start it, it was kind of haywire. By turning it all the way down, it prevents it from being haywire. At least in my case it did. You might not need to do that because you're not really messing with the mechanical stuff. You may be able to start it if your machine sits at an idle properly, then you can move on to the next step. So, step 3, with the generator set running at no load, adjust the speed potentiometer on the governor control to obtain a voltage of 176 volts or 254 hertz. And that equals just a little over 3,000 RPM. Now, probably saying, oh, where do I take that reading from? You're going to go over to the controller, and all the readings that you talk about in this procedure are between A and B on the controller here. Now, what you're going to do, the reason why you have the dial caliper, I already had it down here. I have the dial caliper adjusted to 5/16 on the inside measurement. What you're going to do is start the machine, and when it idles evenly, this magnet should be 5/16 away. And you're going to have it run in an idle, and be careful sticking a metal thing in here with battery and stuff like that. And you want to try to get it right in the middle of the magnet and have it so this is just barely touching each one of those at an idle. This is probably the most critical thing to do. You're going to loosen this jam nut. Screwing this in will adjust it inward, and then screwing it out will pull it outward. I think I have that right. Anyway, I feel stupid. I should know that when I'm sitting here making the video. But anyway, you'll know it. It's pretty obvious. So if it's not 5/16, you start the machine, let it idle, get an idea of where it's at, shut it back down, loosen the jam nut, adjust it. Get that to really where it needs to go. That's important. So step number 5 here, turn the stability potentiometer on the governor control clockwise until the engine becomes unstable, then counterclockwise until it stabilizes, and then just a little bit further counterclockwise. That's the one that says stab. So you're slowly going to turn it clockwise, and then it'll go from smooth. You'll hear the engine start to not idle so smooth, and then it'll go where the magnet's going to grab like it's shutting down, then it's going to let it go, and it's going to open all the way up, and the engine's going to brum, brum. So when it's doing that, then you go back to moving it counterclockwise very slowly. Do it a little bit, and then say let it stutter. I think I did it like twice or 3 times, And if it improves a little bit, keep going a little bit more, keep going a little bit more until it doesn't do it, then just the smidgen more. Then you're going to do the same exact thing for the gain. On my machine, the gain was much more of a pain to get adjusted than the stability. And that was number 6 I just talked about. So, once you get all it stable at idle, you're going to apply rated load. Rated load is 3,000 watts. Now keep in mind, you're better off using some items to make a load on this that are a 1 power factor. Really quick lesson on what power factor is. Power factor is basically what percentage it is. For example, most military stuff like this gauge, it's a 0.8 power factor. What that means is it reads 80% of what the load actually is. There's certain things that have different power factors, and 0.8 I guess is just something where the military said that's going to be somewhere in the middle of everything that we might hook up to this, so it's going to be in the middle to give an average good reading from most stuff hooked up to it for the soldier to understand, or the Marine or the airman, whoever is using this out in the field. But for the testing purposes, for example, a lot of people use like space heaters. On mine, I was using like some blow dryers and stuff like that. I was actually using about 3,100 watts, but it was only showing it, say, 26 or 2,700 on the meter. I actually was going over the load of 3,000, which on the meter is the 3.0. So read whatever the actual wattage rating is on the devices that you're plugging in to make sure that you're at full load. Don't go just by this gauge. So anyway, going back, you're going to apply the full load, and you're going to take a measurement for 194 VAC, which is volts, or 288 hertz. And that means it's just a hair under 3,500 RPM. That's at these here again. If it's not there, there could be 2 reasons why. If your mechanical governor wasn't messed with, then more than likely what it is you're going to have to adjust the boost. The boost is that 3rd potentiometer right there. So you're just going to make a little adjustment on that, take your reading again. Make a little adjustment on that, take your reading again. Now what I noticed on mine, because my mechanical governor was messed with, is I was adjusting the boost, and what started to happen was, well, it's not going to happen now, but this started to raise up out like this. You can actually see it a little bit if you watch my little how this project's coming along video that I posted as well. And what that problem is if your mechanical governor is not set right, what happens is there's not enough pull upward with the spring back there. So the spring isn't pulling the fuel lever up to match where this controller wants it to be. And then the controller, as smart as it is, doesn't know that that isn't happening. So it continues to open and open and open until it's completely maxed out to where it can go, trying to increase the throttle of the engine. So what my problem was that I noticed on mine is I had this screw screwed down too much. What I suppose could happen on your machine, even if this wasn't messed with, is this little thumb screw right here. This thumb screw is like a manual throttle lock that this Yanmar L70AE engine comes with, so it can be used on an application. Say if this was being used as like a small trash pump for moving water or sewage. You move it down to the start, you screw it, you start it, and then you can throttle it down so it doesn't use as much fluid to move the water that you need to. And in the case of the way this governor works, is it ramps the engine up to create more amperage of DC power for the inverter, which then gives you clean power alternating current, 240 or 110 volt here. So you either need to adjust the screw and loosen this, because I don't know if I'm going to be able to record it, but that screw comes back, you can kind of see it in there, and it stops this from being able to be adjusted down. So that could be your problem if this screw is messed with, or maybe this nut came loose on yours or was adjusted and it's only set, say, halfway, or it vibrated loose and it's all the way down near stop or something like that. So loosen it, move it all the way down until it hits that stopper, and tighten it down. And make sure it's snug. Then put it back, start the generator back up, put it under load. Obviously you should shut it down before messing with all this stuff, because it'll send this going all haywire. Then put it under full load again, and it should stay where it needs to stay. It shouldn't lift out of this at all at any point if all this stuff is set properly. It's either going to be a control adjustment at high idle over at the boost over there, and then you want to make sure it's not lifting out and go up to this. So now what you're going to do is take the load back off, and you're going to monitor and make sure that it comes down slowly like it should, and make sure that the magnet doesn't grab the target. And you might want to let it run under load for a little bit, because I initially adjusted mine. It did pretty good, but then when it ran for a little while and I took it off, the magnet wanted to catch and it stuttered a little bit. Yeah, if it stutters a little bit, what you do is you come back over to your controller and you just turn down the gain ever so slightly. Then try it again. Put your load back on, let it run at load for a little bit, and shut it off, and make sure that it's a nice steady ramp down. It shouldn't stutter or anything. The last part, it says at no load, lift the actuator lever and lock it in the manual start position. The voltage should be 219 volts or 317 hertz. This is your manually starting lever. You push it in, and that's what you do if you're going to use the manual pull start, which I don't have in mind right now. And then while it's running, it wants you to do that while it's running, and then take that reading across the A and B again. So, pull this out. One of the last problems that I had, it was actually the first problem I had, and I had to do a ton of troubleshooting to figure out exactly what it was, is you go to shut it off, and the magnet will pull in like it wants to shut it off, and then what'll happen is the engine will just say brrr, and it stays at like a very, very low idle, and this doesn't actually shut it off. And that'll be whether you shut it off at the switch or the emergency stop, and you'll actually, all your gauges and stuff will die out as if the generator is off, but the motor won't shut off. What happened is the controls thought it shut the engine off, but the engine is fed fuel from inside the lines and stuff mechanically. So it would eventually probably stall out and shut off because it would lose prime, but it's continuing to feed fuel from like the line here and stuff. what the problem was on mine, and I wish I realized this first because I probably wouldn't have needed to readjust everything, but I had just put my throttle in the middle, and what was happening is it was the opposite of the problem I described with it ramping up with the spring. Just like you have a spring that increases the throttle, there is another spring that is way down in there that you can kind of see coiled up that is for shutting off. So when you have the mechanical throttle and governor set somewhere in the middle, that's actually increasing the spring pressure that lets it shut down, so the magnet can't overpower it. So all of this is finding the sweet spot. Now, in a perfect procedure, you would go pretty much in the order I just explained and do everything once and figure it out and be happy. But I spent a whole bunch of time with this. Again, I was sort of learning too, because there's no procedure in the TM for this being adjusted. But anyway, like, you may come over here and get everything good on the controller that's inside the panel, and then realize that you were off a little bit on that 5/16 gap here, or your throttle control over here, and it's going to mess everything up, and basically you got to start over. But once you do it enough times, you know the procedure, and it goes a lot faster. And then again, make sure you tighten up after your adjustments all these nuts really good, because you'll vibrate. And one of the things that took me time, I think I already said this, but this actually came adjusted and that 5/16 was off. I thought I had it running all good, and then it was having a problem coming down and ramping up properly, and that's what it was. This is like really the best that I can explain to do this. Don't really know any better way to do it. I did a whole bunch of reading for hours and hours and hours on Steel Soldiers about people doing this. They put bits and pieces of this. I'm just consolidating it all into one video where I talk about it, show it, tell you where it is in the TM. The one last thing that I'm going to talk about is, with this, say you go to make some of these adjustments and you're getting no response when you adjust anything on the potentiometer here, or anything on the speed controller with one of the potentiometers. Say like you turn your stability all the way up during that procedure and the motor never ends up stuttering. It probably means you have a bad speed load controller. These seem to be the weak point for these generators because it's analog. Analog always has stuff that can go wrong with it. If moisture, dust, extreme temperatures and everything goes in. I got lucky and mine seems to work. But somebody on the Steel Soldiers forum actually engineered a digital control replacement for this that is awesome. So if you have a problem with this, he sells that for I think $180 on eBay, and his username is like Klopk, Kilo, Lima, Oscar, Papa, Kilo. Look it up on eBay, and he sells the replacement, and it's plug and play. I mean, he labels it so you can take these wires, you will put them same number or same letter locations that's on here. He made the holes match up. It's a green circuitry board, labeled. He seals it when it's done. And how you have to go through and do all these adjustments like I just showed, you don't have to do that with that. It has a little microprocessor that he put in it, and it makes the adjustments for you that these potentiometers would manually do. Now you might ask yourself, well, why in the world wouldn't the military have just put that type of part in here? Well, the reason why they didn't do that, one, these actually were designed quite a long time ago, so they were ahead of their time. Two, the military tries to make everything as EMP proof is possible. EMP is an electromagnetic pulse, and what that does is it fries computers and stuff. That's not to say that this thing can't be near an EMP and not go bad, but when you have analog controls, analog stuff is hard to destroy compared to digitally controlled, say, microprocessor or computer chip. That's the reason why a lot of these military units tend to have like all these crazy controls. Then when you look inside something, say like a Honda inverter generator that's gas, and it's got like a couple wires and one little controller. That's the reason why these look so much more complicated. But yeah, I'll put a link to my thread on the Steel Soldiers forum about my fixing up this MEP 831 alpha generator. I will put a link to eBay for his listing for his replacement controller, and I will also put a link to the Steel Soldiers forum where the technical manual for these generators are, along with the link to this kind of shortened go through on how to adjust it so you can go along with me. Yeah, so hopefully this video is helpful. Let me know if it was. Let me know if you watched this and you went through and you found some error, so that way I can correct the video, as I don't want to be putting bad information out there.